Hello everyone, welcome to my channel. This is Vijay Lakshmi. Today we are going to discuss about Bayes algorithm. So here given a sample data set with 4 attributes and one target output, that is the job offer, we have to classify whether the student is going to get job or offer or not based on this independent variables. So here the first step to apply this Bayes algorithm is we should compute the prior probability. Step 1 is compute the prior probability for each of the attributes whatever they have given. So here first we should compute the prior probability for the target class. So in the target attribute, identify how many S and how many no's are there. So here we have S, 2S, 3S, 4S, 5S, 6, 7S. And how many no's we have? Out of 10, 7 are positive and the remaining 3 are no instances. So write here job offer class. S is how many? 7. So we write the probability value as 7 by 10. And how many no we have? 3. So we write the probability value as 3 by 10. So in step 2 what we do? We compute the frequency matrix. We compute frequency matrix and the likelihood probability of the attributes. So that is the likelihood probability we say. So next, consider the attribute CGPA. So in CGPA, if you see, for greater than or equal to 9, we should count in the target job offer how many S and how many no's are there. Similarly, for greater than or equal to 8, here in the job offer you have S, and in the instance 5 also you have S, and instance 9 and 10 if you observe here you have S only. So here how many S are greater than or equal to 8 and how many no are greater than or equal to 8? We have to count. Similarly, for less than 8 also, how many S are there and how many no's are there. So here less than 8 we have 3 no's. Just count by seeing this. So we have listed in the table, we have greater than or equal to 9, 3 yes and 1 no. So what is the probability of this one? So to find the probability for all, first you list out how many S and how many no's are there. Greater than or equal to 8 we have 4, less than 8 yes we have 0, and greater than or equal to 8 no you have 0, and here you have 2. Now for this, find what is the total instances of S for the CGPA. How many are S? So 3 plus 4 it is 7, and here 1 plus 2 it is 3. Now for this, considering this, how many are positive now here? So okay, for this one now we are writing for S likelihood priority probability, that is 3 are positive out of 7. It's an evidence of 7. P of H by E we are writing now. Similarly for no, probability of no, here we have 1 by 3, total is 3. Out of total 3, 1 is no. And similarly for greater than or equal to 8, we write it is 4 instances out of 7. Likelihood priority. Occurrence of no with an evidence of 3. So that is, we write it as, for this we have totally now, for no instances we have 2 by 3 here. And for no here greater than or equal to 8, you have 0 instances out of 3. So we write the probability value for no as 0 by 3. And similarly here, the probability value of no, here no instances are 1 out of 3. So here likelihood priority will be 1 by 3. So like this, for all the attributes, okay, for all the attributes, that is for practical knowledge and communication skills also, we have to compute the likelihood priority matrix and the frequency matrix. So here for the interactiveness, so for S and no, how many S we have? 5, and no are 1. So see the job offer column. And similarly for no we have 2 S and 1 no. So totally we have how many instances? 5 plus 2, 7, and here it is 3. So here we write the likelihood probability, that is for yes, P of S, that is 5 by 7. P of no, that is 1 by 3. Similarly for the no in no category, it is 2 by 7 probability of S. And no is how much? 2 by 3. And just here put 100%, 100%, or just you can put hyphen for the total. Okay guys. So similarly for practical knowledge, we have 3 attributes, very good, good and average. find how many yes and how many no's are there in the job offer column. Then probability, then totally we have 7 and 3 here. So how many yes are there? 2 by 7, probability of yes. And probability of no is what? 0 by 3. So probability of no for the practical knowledge. And probability of good for practical knowledge, occurrence of good for practical knowledge, here we have 4 out of 7. So we write here as P of 4 by 7. Similarly, for no, we have 1 by 3. So 1 by 3. For average, 1 by 7. We write it as 1 by 7, probability of S. And probability of no is what? 2 by 3. So that's what we have written, 1 by 7 and 2 by 3. Just put here 100% or hyphen. Similarly, calculate for communication skills. So here we have good, moderate and poor. And we are calculating the probability. Here 4 S are there and totally we have 7 instances. So we write here as 4 by 7. And here 1 no you have out of 3. So here probability of no is 1 by 3 for the practical knowledge. Similarly, here we write it as 3 by 7 probability of S and 0 by 3 for probability of no. And it is for poor we write it as totally 0 or S, 0 by 7, and for no we write it as 2 by 3. So this is what all the frequency matrix is computed. In step 3, what we do, using Bayes algorithm, we calculate the probability of all hypotheses. So using the Bayes theorem, we are going to calculate the probability of all hypotheses. That is P of hypothesis on evidence E is equal to P of hypothesis on evidence E already occurred on some hypothesis into P of H divided by P of E. So this is the Bayes formula. We are going to apply this Bayes formula now. And this P of E for max, we don't consider this P of E denominator factor. Okay, guys. So now if you see now for Bayes algorithm, now I'm going to write what is the evidence on some hypothesis. That is P of job offer on S. Okay, on S, what is the probabilities of occurring on S now here? So here on S, just see for each of the attribute. Job offer was what? P of EH was 3 by 7. That is, yes, job offer on S. See the first attribute, that is CGPA. Okay, so here job offer when CGPA is greater than or equal to 9 for all the attributes. So here, if you see this, it is for CGPA greater than or equal to 9 for the first instance, it is 3 by 7. So we take 3 by 7 into the next attribute. The next attribute is interactiveness on S. So here all on S we have to consider. The first attribute here is yes. Okay. Yes on, for what is probability, likelihood probability of interactiveness on S is 5 by 7. So now we wrote 5 by 7 here. Into next practical knowledge, if you see practical knowledge very good on likelihood priority of 2 by 7, likelihood priority of yes, that is 2 by 7. Into for communication skills for good, you have a likelihood priority of 4 by 7. Substitute that 4 by 7. Into we write the hypothesis of the positive hypothesis of the overall problem, that is 7 by 10 we have calculated. So that is into 7 by 10. So max of E of H into P of H we consider. So this is max of P of E of H into P of H. So that is called as a maximum posterior hypothesis. So we are computing now H map, maximum posterior hypothesis, taking all the S attributes into consideration, considering the first category for all the attributes whatever we have seen here. So here job offer yes, we got it as 0.035. Similarly, job offer no or no we are computing now. So no or no for all the 3 attributes. The same way here. So go for the first attribute. So here job offer for probability value you have 3 by 10. So this should be multiplied at the end. This 3 by 10 job offer. Okay, this one will take at the end. Now for CGPA greater than or equal to 9, probability of no is what? 1 by 3. Okay, this 1 by 3 into job offer no on no. So 1 by 3 into, see the practical knowledge here, what is the job offer? No on no. So no on no it is, yes on no, sorry, the first attribute, yes on no, now we are seeing. So no on no, job offer no on no, that is. So it is 1 by 3. Okay, this 1 by 3. And for practical knowledge, again for very good, what is the job offer no you have here? 0 by 3. So substitute that 0 by 3 here. 0 by 3 into, next we have for good, probability of no is 1 by 3. So this 1 by 3 into this 3 by 10 is the first job offer priority probability. The priority probability what we computed at the first step is, for negative instances it is 3 by 10 and for positive instances it is 7 by 10. Totally 7 positive and 3 negative. So here job offer no on no, what you are getting? You are getting it as 0. So this is an evidence. If job offer is no on no is, what is the probability of occurrence is 0. Job offer yes on yes is 0.035. Next, what is the sample data set given to us? So see the sample data given to us, sample data set, that is, if CGPA is greater than or equal to 8 and interactiveness should be S and practical knowledge should be average, communication skills should be good. So if these are the input data given, what is the probability of occurrence of the job offer event, yes or no? So this is the data given for CGPA greater than or equal to 8. Here we have done this example for CGPA greater than or equal to 9, considering all yes and considering all no. Okay, next what we have to do, just for the given data set, again find job offer yes on yes and job offer no on no. So here job offer for CGPA greater than or equal to, see here, for this now again CGPA greater than or equal to, go back to the previous tables. See here, what is the probability value for CGPA greater than or equal to 8? Positive instances, this is P of S is 4 by 7. Okay, this 4 by 7 into, you should see the next column. Interactiveness is yes, he has given in the data set. So go to the interactiveness table. When interactiveness is yes, what is the probability of yes here? It is 5 by 7. Interactiveness is yes, so it is 5 by 7 into, what is the next attribute given? Practical knowledge on average. So on average, practical knowledge. So here you see the average. So here take only the positive instances, that is probability of occurrence of S, that is 1 by 7. On average, if you observe here, on average we have probability value as 1 by 7. And next is good, communication skills should be good. So communication skills good in this table, if you see good, the probability of this one now occurrence of that event is 4 by 7. So here next what we are doing, we are multiplying all now, all the S instances. So 4 by 7 into 5 by 7 into 1 by 7 into 4 by 7 into, okay, this into this prior probability, that is 7 by 10. So you will get yes on yes as 0.023. Similarly, for job offer no on no, for the same sample data set, job offer no on no. So go back to the same tables again, just for the same sample data set given. Okay, for the same sample data set given, we have to take the probability of occurrence of event as no, that is CGPA greater than or equal to 8 when no, interactiveness yes of no, and practical knowledge average no, and communication skills on good no. So go to the first table, and here if you see here, for CGPA greater than or equal to 8, we have 0 by 3. Probability of no is nothing but 0 by 3. This into, okay. Next, see the interactive table. So in the interactive table, for the attribute S, okay, when job offer probability of occurrence of event when it is no is 1 by 3. This 1 by 3 into, again for the attribute average, he has given probability of no is what? For the attribute average it is 2 by 3. Take this 2 by 3 into, for the attribute good, okay, for communication skills good. So here for communication skills, what is the probability of no? That is 1 by 3. This into the probability of the prior probability of the sample data set. So we should multiply together. So that's what we have multiplied here. So 0 by 3 into all, if you multiply, you will get the job offer no and no as 0. You're taking all the no's, okay, for the sample data set given, and here we have taken all the S from the sample for the sample data set given. And next what you have to do, you are getting the result job offer no or no, you're getting the result as 0. And here for job offer S on S, you are getting as 0.023. Okay guys, so here whenever the probability of occurrence of that event becomes 0, when the model is predicting 0 means, then we have to do the Laplace correction for this one. So Laplace zero error correction has to be done for the 0 where this 0 is present here now. Okay, so because the model once we compute this, the next step is whichever model has the highest value, that will only be the prediction. But here the highest value to compare, here we have 0.023, but we have 0 here, so we cannot properly compare whether it is the model is going to predict job offer as yes or no. So that is why we have to do the Laplace correction. For Laplace correction, what we do means we add one additional instance for each of the attributes given for the sample data set. For example, if you take CGPA now, so here CGPA greater than or equal to 9, greater than or equal to 8, less than 8. We had totally 3 instances, right? We have written 3 by 7. Just now we assume it for 1000 samples. If there are 1000 samples, if I add an additional one sample for each of this category, my result will not be affected much. So that is the reason, that is what the Laplace correction says. It's just we changed that 10 samples as 1000 samples. Just rewrite how many instances we have: 300 by 700, 400 by 700, and 0 by 700. So we had 0 by 7 there in the table. Just replace it, scale it for 1000 instances. Similarly, no, we had 1 by 3 for 10 instances. Now we are scaling for 100 instances, so we write it as 100 by 300. And here it is 0 by 3, so we write it as 0 by 300. And 200 by 300. Now, what is the probability of occurrence of no here? Probability of occurrence of no, why we are considering? Because for no only, job offer, no and no only, we got the result as 0. So that is the reason now we are doing modification for this one. So probability of no. So totally we had how many instances here, guys? So here for no we have 100. We are going to add one additional instance, I said, right? So we are adding one additional instance for greater than or equal to 9. So it becomes 101. Okay, so 101 divided by, totally we got out of 300 no instances, we added plus 3 instances. So plus 3 means it becomes 303. And similarly, for greater than or equal to 8, we add one instance. So this becomes 1 divided by 303. We added one additional instance, that is why each time it is changing. And then 201, add one instance for less than 8. So this becomes 201 divided by 303. Okay guys, same now, take scaling to 1000 instances, just remodify that job offer S on S. Instead of 4 by 7, we write it as what? 400 by 700 into 5 by 7. Already we have computed here, if you see. So here we have computed 4 by 7. Just write it as 400 by 700. And here you have 5 by 7 here. Write it as 500 by 700. And similarly, for all the attributes given here, just see here, you have 1 by 7, make it as 100 by 700. Similarly, for all you have 700 by this one, 10, 7 by 10 means, so it is 700 by 1003 is our total instances. So find job offer S on S, you will get 0.023. Now job offer no on no. Job offer no on no also, now we have changed the total number of instances. So that is 1 by 303. The total instances is what? Totally we have here how many? A job offer no on no. We had 0 by 3. If you observe here, we have 0 by 3. So we added one instance there. So it will be what? Job offer greater what for CGPA greater than or equal to no. We have here probability of no is 1 by 303 in 2. Next is what? 100 by 300. Same as the previous one, like how we have done. So 1 by 3 is written as, here we have here 1 by 3. This 1 by 3 is written as 100 by 300, and similarly 2 by 3 is written as 200 by 300. Okay, and similarly you have now 3 by 10. 3 by 10 means totally we have 303 no instances divided by 1003. Since we added plus 3 instances, only that for the no we have to update the values. So you will get now the result as 0.00002215. So it's simply getting 0.0. So you got some value. Okay. So now we have to make the prediction. What will be the result? Whether the student is going to get the job offer or not. So compare both the results. So here job offer S on S, it has the maximum value. So the model predicts the result as job offer yes for the student. So this Laplace correction is done whenever we have a result as 0. Otherwise, no need to do the correction. So here, if you observe the beginning sample data set, the first step what we have considered here, that is this how we computed now in step 3. If you see here, we are taking only the positive instances. Here, simply instead of writing the data set, we have taken all the positive instances with job offer yes for the first attributes. Okay, first attribute sample data set. This is what we have taken here. So we computed yes and no. So this was our prediction. Okay. Here also we got 0. We should have applied Laplace correction. Since this is the first example we took, so we didn't do that. Now similarly, if you see for job offer, for this is the second sample data set given. For this again we saw that it needs some Laplace correction. So I think hope you have understood. And please don't forget to subscribe to my channel. Please like, share and comment. Thank you.